Hi everyone, it's Mr. Kennard again. This is investigation 4.2 B. Talks about some more about our liquid expansion and contractions. That's right, you wanted more, I'm giving you more. We're going to continue a little bit with what's happening with those particles as they get heated, as they get cooled, as they expand, as they contract, and more fun stuff for you. So hang tight. We ended last time with what we thought about a real thermometer and how that works. What happens when you put the thermometer into the cup of hot water? Again, we had said that the particles are they're gaining heat, and therefore kinetic energy, and therefore moving faster and farther apart. So what happens in a thermometer is they move faster, they move further apart. What if you put them in hot water? Those particles inside the tube then get excited, get more kinetic energy, they need more space. The only place for them to go is up the tube, recording a higher temperature. And all thermometers will work that way if they're filled with liquid. So, give you an idea about that. So let's do a little summary of our kinetic energy, compression, contraction, and expansion as we've talked about so far with gases and liquids. What I'd like you to do is to pull up that KIM vocab term and add these ones to it. Again, compression is when the decrease of gas volume, meaning it gets smaller because of pressure. Contraction is due to a decreased kinetic energy when it gets cooler. And then expansion, that is the volume, increase in volume, can be either forced or by increased kinetic energy. And again, our kinetic energy is the energy of motion. If you're moving, you have kinetic energy. If a ball is rolling down the hill, it has kinetic energy. If a truck is moving, it has kinetic energy. And so those are the terms you're going to need to add to your vocabulary list using that KIM form. Save those to your notability page. Next thing I'd like you to do is to read or have read to you the particles in motion on page 33. It's a short little thing. Again, you can have it read to you, so it's not too bad. In your FOSS ebooks on those web pages, that's the one to use. The ebooks by FOSS. You have a tab or an app that works there for you. Go ahead and click on that. You should have downloaded. You'll have to log in with your FOSS web and stuff. And then read over the particles in motion. All substances are matter made of particles. Does this include invisible air? It goes into more detail about what we've talked about with some more illustrations as well. We'll have some follow-up questions on this. Great, you're back. What we want to do next is I have a discussion board response for you. In investigation 4, here's a response sheet. A student filled a syringe with water and left it by the sink in the sunshine. 10 minutes later, she saw a little puddle of water under the syringe tip. She said, "This syringe must be broken. It's leaking." But the syringe wasn't broken. So in the discussion response, I want you to, what do you think caused the little puddle of water to appear under the syringe tip? So in the discussion, you're going to answer this question. What do you think caused the little puddle of water? And also, make sure you use the particles and the kinetic energy in your explanation. All right? Put this into an applicable, a real-life example of what we've seen so far with heating and cooling of gases, and in this case, with liquids. Go over to the discussion page and fill that out now. In addition to those other vocabulary terms, we want to focus on 2 more ones to look up and to be able to look at and explain. Temperature. Temperature is the amount of kinetic movement, kinetic motion that there is, kinetic energy that there is. When you think about if it's hot outside or cold outside, that is a measure of, I'll write this in here, measure of the kinetic energy. So temperature of something. We think it's hot, we think it's cold. It's really just a measure of how much movement of those particles it is, whether it be a gas or a liquid. And a thermometer is just a tool to measure the temperature. A thermometer will help us measure that. It will use its particles to show us what the particles of whatever it is we're measuring the temperature of. So include those also in your table of contents. Use that in a KIM form as well. So in summary, we can wrap this all up. What happens to the particles in a sample of liquid when the liquid is heated or cooled? If it's heated or cooled, they expand or they contract. All right. So far we've seen what happens when we heat and cool gases, when we heat and cool liquids. Next lesson we'll find out what happens when we heat and cool solids. See if this trend continues. Thanks for listening, everybody. Go ahead and make sure that you turn in all of your work for this one. Answer questions on the discussion page. Add those vocabulary terms to your vocabulary section. And we'll see you next time talking about solids, heating and cooling. Bye.